In this video, we're going to take a look at the Adam Savage's tested VR headset experience. And so to get to the app, we're going to go to our Oculus Quest app on our phone, and then we're just going to search Adam Savage. And it should be the first one that pops up for you. So we're going to download this app, and this app basically allows you to go into the workshops of a bunch of creators and experience what they see and kind of see how they build and what their building process is.
Hey there, Adam Savage here, and welcome to Tested VR. You are inside my cave, my sanctum, where I make all the props and costumes and objects that I can't not make, like this one here. And in this series, you're going to get to experience a build from me in this space, but we will also be taking you inside the workshops and maker spaces of incredible makers and designers from all across the country. From costumers to creature makers, from puppet masters to chainsaw sculptures, you're going to get a unique view into their working process, their design aesthetic, and the spaces in which they work. So pick up a notebook, have a look around, and enjoy. Adam Savage here in my cave, and just like you, I love robot gladiatorial combat. In fact, I've been partying to the sport almost since its inception in the early 90s when it was called Robot Wars, run by Mark Thorpe. Jamie designed and our team helped him build Blendo, the very first centrifugally destructive machine, and we were awarded first prize in lieu of competition because our robot was too dangerous. Mark Devitz is a veteran competitor in the same sport, and he leads Team Icewave. And we're going to head over to his shop right now as the team puts finishing touches on the robot Icewave to get it ready for its next combat.
Hi everyone, my name is Mark, and I'm the captain of Team Icewave on BattleBots. BattleBots is a TV show where we build and fight robots in a bulletproof arena, so things get pretty beat up. Today, I brought in the engine so I can show you guys how Icewave works. We can take the cover off, take a look inside, and we're also going to be doing some upgrades to the engine for a future season of BattleBots. You can see here things get pretty beat up when we go into that arena. So let's take a look. We'll go into the shop and I'll show you more. Okay, so let's talk about the anatomy of Icewave. Icewave is made up of essentially three different parts. The base, which contains the wheels and the electric motors and the batteries, and that drives the robot around on the floor. Then on top of that is a 50-pound blade. This blade is made of S7 tool steel. It's hardened so that it actually can cut through other S7 tool steel that's not hardened, and it will survive longer than that. Take a look at this blade here. This actually once was the same exact blade as this one. And this happened in a fight with a vertical spinner. You might have heard of him named Bite Force. And you can see this hardened tool steel basically shattered like it was glass. So this is the kind of thing that we're up against when we're fighting other robots, especially other really good robots in the arena. This is another good example here. This is a front wedge hinge This is actually part of the front wedge of IceWave, bolted on right here. You can see that once spanned the entire length of IceWave, but now it's completely shattered into a million pieces, and that used to be our poor little logo right there. But you can see what happens when even 1/4 inch or 1/2 inch thick steel goes up against some of these other robots. It's like it's nothing. So a lot of the damage that we incur is really to the base, and we try to protect our engine as much as possible because it's really not well protected. The blade is what's protecting us. And then on top of that is an engine. But let's power up this base, and I'll show you what the drivetrain looks like. So the way we drive IceWave is actually just with like a standard RC car controller. And what you'll see a lot on the TV show is people going in and turning on the robot in the arena before the match starts. What they're doing is most of them are using these power switches, which we get from another competitor, that you actually turn them and they lock on so that they can't fail in the middle of the fight. So what you're seeing is they're unscrewing a screw, which essentially turns on the robot and locks it on. So this base is basically fresh. We've cleaned it up since the last season, and all the chains are lubricated and everything. You can hear the speed controllers running. Those are just the fans that keep the speed controllers going. But essentially, you just drive it like an RC car. And so what you're hearing there is the speed controllers pulsing the motors. So as you go faster and faster, you'll hear it get louder. So I have full control over which direction the robot goes, all from this one stick on the radio here. So you can drive forward, backward, left and right, all from this one stick, which frees up the other sticks on the radio to do other things. But we actually use a completely separate radio for all of our other things, because just doing that alone is enough to keep your mind occupied while you're driving a robot. So this is the engine that you've seen on IceWave for the past few seasons. This outer shell is actually really thin. You may have seen some fights where we've gotten completely destroyed and that shell gets torn up like it's paper because it's only an 1/8 inch of aluminum. That's mainly because the weapon on IceWave is our active armor. And so this is basically a dust shield. What's inside of here, though, is a 15 horsepower gas engine from a concrete saw. So what we've done is we've taken a concrete saw that we bought off of eBay, and then we cut all the different pieces off of it and shrunk it down into a size that fits inside of this box. And we've added an electric starter to make it safe so that we can start it remotely. We've added the gas tank and the exhaust pipe. It's completely different than what you would see on the concrete saw. But essentially this engine powers only the blade. So all 15 horsepower of this engine goes directly into the blade through a belt and a chain system. The engine on IceWave is really where we spent most of our time the past few seasons. It's the thing that gets broken the most. So it's the place where we spend most of our energy on making repairs and doing upgrades. So let's take a look at what we're working on for the engine for next season. So let's talk about the anatomy of the engine of IceWave. So this is the same engine that we've been using for the past few seasons. Like I said, this engine comes from a concrete saw. So we essentially buy a saw and we remove all the pieces of the saw that we don't need anymore, and we're left with this relatively small engine that comes with the crankcase and all the stock pieces, and you can see even the pieces here that we've removed. So right here we've removed the rest of the saw, that's where the blade goes, and this is the all stock engine. We removed the muffler and put a straight pipe on here. We keep the same carburetor. So a lot of this engine is very stock, just with some pieces removed. But essentially this saw comes from a concrete saw that people carry around all day while they're working construction jobs. So this crankcase is made out of cast magnesium, so it's super lightweight and durable. The problem with cast magnesium is very brittle. So when you start getting jostled around in BattleBots a lot, you start to notice that the crankcase develops these hairline fractures, and over time those fractures basically kill your engine while you're in the middle of a fight because you lose all your compression or the whole thing just splits apart. So really what happens in the last couple fights we've had, they've been so intense that we've been replacing this crankcase on every single match. That just gets to be really painful. Every time you want to try to take a break, you can't because you have to replace the crankcase and rebuild the entire engine. So The big upgrade for the next season is we're actually taking all of the internals that work really well on this engine, we're extracting them from that engine and building our own billet crankcase. So this is what the billet crankcase looks like. This is something that we've machined here custom in our shop, right here on this machine. And all of these pieces go together to essentially recreate what you see here in a much more robust package, and it's a lot more compact as well. So with this crankcase, we're able to mount the starter motor right onto it and use a stock starter motor, not something that we've had to piece together ourselves. And then, we're taking a lot of the existing pieces that work really well, like this head. This just bolts right on, and we don't have to worry about that. We can put the piston in there. We can essentially rebuild the same engine in this new crankcase. The only thing we had to worry about was getting the volume of this crankcase correct so that it matches the internal volume of that crankcase. So what you see here is we've got all these pieces machined to build our billet engine. And once you piece all these together, you can see it's a pretty small package. We fill that up with oil. We put a bunch of gears in here to get the starter motor connected. But yeah, bolt on all the accessories, and we have a lot of things that we've made custom here to make it work, like custom gaskets that we've laser cut. This is a carburetor adapter that we've machined out of high temp plastic called PEEK. That's pretty cool. It's a very high temp material. It's very robust. And this is just a stock clutch that you'd find on the saw, but that works fine. One of the other things that we had a big problem with, and you can see here, is this was actually a custom enclosure that we had machined out of ABS plastic for all of our electronics and all of the electrical controls that run the engine. So what you can see though is this used to be mounted right here. The shock from just the last few fights has completely shattered this plastic into a bunch of different pieces here. So obviously that's got to change. We've got to work on something better. So we built a completely machined aluminum version of this out of one piece of metal here. And that's going to contain all of the starter solenoid and microcontroller that controls the throttle and stuff like that. So you might be wondering, where do we build IceWave? IceWave is built here at my company that I started. This is called Double Robotics. This is our production floor for the product that we actually build during the day. And what we build is called Double. It's a telepresence robot, and that allows people to go to class and go to meetings as if they were actually there when they can't physically be there in person. We started the company in 2012, but if you go back even further than that to around 2005 when I was in college, I started building BattleBots, and I was competing with an early version of IceWave in BattleBots, and that's where I met my co-founder. He was actually working for BattleBots at the time doing their software, and as we kind of became friends throughout the years, we realized that we have a good team working together to do software and hardware, and a lot of the skills that we learned from doing BattleBots transferred over really well into building a product like Double, or really any product, because what you're doing in BattleBots is you're iterating on your design a bunch, and you're trying to figure out what's going to break in the hands of the customer. So a good example, a good story I like to tell is we used to have the wheels on this robot used to have 1-inch axles, and they were solid steel axles, and it was completely ridiculous and overweight, and that was one of the early prototypes of it. That's because we come from the BattleBots mindset of needing to overbuild and over-engineer everything, but we've slowly narrowed down the feature set of the product and figured out exactly what the customer is looking for, and we've come up with something pretty compelling that we are very happy with. Okay, so now it's time to put together the new engine. I've got the old engine here, and I'm taking a few pieces off to try to just piece it together rather than fabricating a bunch of new stuff. Like, I don't really want to make a new gas tank right now. And some of the things are already put together here. I've already bolted on the starter motor, and that's clamped in. And I've got the carburetor on with the old carb adapter. This is the low temp plastic, but it should work fine for a little bit of a test, just to kind of tell us if anything is wrong. I've got this long cable here running to the servo for the throttle, just because I'm not quite sure how long that needs to be just yet. And I've got the spark plug plugged into the electronic ignition module here, so I just got to wire that up in a little bit. Once I get this all together, I just got to see where all the wires are going to go. So the last thing I need to do is flip it over here, and you can see on this side, this is where all the gears are for the starter mechanism. So this is a one-way clutch here that if I spin it in this direction, it's actually turning the engine. But if I spin it in this direction, it's not. So I'm going to go ahead and put this back together. I've got one intermediate gear here that I have to throw in, and that transfers the torque from the starter motor, reduces the speed and increases the torque so that we can actually turn this engine over and get it going. So I got to put this together. That goes on that shaft there. I got to put a couple of bolts in here. We have a seal along the outside edge because this is eventually going to get filled with oil once it starts running. You know, for a long period of time, we're going to fill it up with oil so it doesn't burn out. But I'll get that bolted together, and then after that, the next step is to just mount this engine to this new plate. So this new plate is essentially the same as this, but a different configuration. We've actually taken all of the components on the engine side of IceWave and moved them all the way to the back. So this is the front of the robot. You can picture it here. And we've actually taken all the components and we've put them in the back half of the engine bay. So that actually gives us a lot of open space here, and hopefully will prevent people from getting, you know, to be able to damage that engine because it's so far pushed back. So basically everything that you see here has been compacted by building this engine all as one billet piece. So we're pretty excited about that. Let me get it bolted on here and we'll see what that looks like when it's all put together. So one of the important things about building a BattleBot is making sure you bring enough spares to the competition. Because if you want to get all the way through the bracket at a normal event, you could be fighting up to 10 or 12 different fights. And as you can see, the blades and everything get completely destroyed. Sometimes every fight, your robot gets completely destroyed. This one just got completely shattered. So you see we need a bunch of new spare blades here. And you know, we have CNC machine shafts now. We have a bunch of spares of those. This is what the blade rides on. That's made out of steel. We have a bunch of bottom armor and top armor. This is aluminum and this is polycarbonate. We have a bunch of spares of those. As you drive around the BattleBox floor, they have those kill saws that come out from the floor, so you want to make sure that you're covered there. And if those cut through, then you need to replace that for your next fight. Hopefully it doesn't go all the way through and cut into your electronics. And then of course one of the most important things is the spare blades. So we actually have 3 spare blades here. These are brand new, 50 pounds each. They're made of S7 tool steel and they're super sharp. They're sharpened on a CNC mill and they're water jet cut to the final shape. So they're extremely hard, but we're actually going to send them off to the heat treater to get them hardened even further so that they can hit other steels and not break as easily. So one small problem, of course, when you send it off to the heat treater is that it gets a little bit more brittle. So we could go through a blade every 1 or 2 fights at this rate, at the rate that we have been damaging blades recently. So we got to make sure we have enough spares of those. So we think we're good this time. Okay, so I'm putting a couple bolts in this top polycarbonate armor here just to keep everything down. This is just going to be a test fit, so we're going to see if the blade fits on here. Blade should be fine, nothing's changed on that, and then we'll put the engine on to see what that looks like. So these 2 bearings sandwich the blade together and keep it from wobbling once you tighten down on the bolt up there. Main thing I'm looking for is just clearances all around, making sure the blade's not scraping anything. Everything looks good here. This is an old blade, so it's a little bit bent, but looks pretty good to me. Now we can go ahead and throw the engine on top and see what that looks like. I'm really excited about this new engine because it's a lot more compact. We've kept a lot of open space here in the front to prevent people from getting in. If you look at the old engine, it's just so much more streamlined now than it was before. So hopefully that prevents people from getting to us and keeps our engine running a little bit longer than it has been in the past. But thanks so much for coming to visit us at the shop where we built IceWave, and we'll look forward to seeing you at the next season.